Hi there. So today's video is just an extension of the dimensional analysis that we've been looking at for the past few. In today's video, we're just going to be going into some specific examples that may be a little bit more complex. So we're just going to give you some hints as to how to solve those. So the first type of problem is, we say density problems, but it doesn't really need to be just specifically density. It could be any problems where the unit that you want to convert is in, let's say, meters per second, where there's a per in it, where there's a division. What you do for those is you change that conversion factor into a conversion factor system that you are more familiar with an equal sign in the middle. So look at this first example. The density of mercury is listed as 13.4 grams per centimeter cubed. What does that mean? That means that 13.4 grams of mercury will have a volume of 1 centimeter cubed. That those two quantities of mercury would be equal to each other. Since those two quantities of mercury are equal to each other, that's a conversion factor. So we can take the per sign, the little slash, and basically I change that into an equal sign. Then it looks like a conversion factor that we've used many times where you put one side on the top and one side on the bottom. Now in terms of significant figures, this 13.4 part, or the number part of the quantity, will have significant figures. So I would say that 13.4 has 3 significant figures. The 1 part, divided by or equal to 1 centimeter cubed, we're just not going to count that for significant figures because we have defined that exactly 1 centimeter cubed will have a mass of 13.4 grams. So this example that I've used is for the element mercury. As long as you have the density for any element or compound, you can go ahead and use this method to convert either from mass to volume or volume to mass. Number 34 says the density of mineral oil is 0.835 grams per centimeter cubed. That per I'm going to change into an equal sign. What is the mass? So circle the do. The question's asking me for the mass. If a sample of mineral oil that has a volume of 2.50 centimeters cubed. So this and the density, those are both my clues. First thing I want to do is read the problem, find the conversion factor, and write it out in the format that we're used to. So I'm going to take this density and just rewrite it as 0.835 grams equals 1 centimeter cubed. Now I continue with the problem in the fashion that we've been doing for the past few videos. So 2.50 centimeters cubed, right? Whatever unit is out front has to match the unit down bottom. So I'm going to put the 1 centimeter cubed on the bottom, which means 0.835 grams is going to go up top. There's the unit that matches. Okay, so now in my calculator, I take 2.50 and I multiply that by 0.835 and I get 2.09 grams, right? I'm using 3 significant figures from the 2.50. That 0 is at the end and there's a decimal point. That means it's significant. This number has 3. The 1 centimeter cubed doesn't count. So my answer should have 3 significant figures. Okay. I know that we have done density problems in other videos where we've used the formula, density equals mass over volume. And you could use, this is just another way of doing these problems, but I want us to learn how to use dimensional analysis. That's a very important skill. So I'm going to ask that if the question says, using dimensional analysis, that you do use dimensional analysis. Or if the question says using the formula, you're going to use the formula. So we're going to move on to number 35. And again, if you feel like you got this, you want to give number 35 a try, do this one on your own and pause the video here. And if you want some more assistance with it, just follow along. The density of aluminum is 2.7 grams per centimeter cubed. That's a clue. What volume, that's what I need to find, of aluminum will have a mass of 10.25 grams. So I first take my conversion factor, 2.7 grams equals 1 centimeter cubed. So I take my fractional unit and split it out into a conversion factor that looks like my typical conversion factors. 10.25 grams goes out front. I make a parenthesis. I put my conversion factor in so that the units cancel out. So 2.7 grams is in the denominator and 1 centimeter cubed is in the numerator, right? So that those two units will be the same so that then I can cancel them. In my calculator, 10.25 divided by 2.7. When I do that out, I get 3.8, and that's centimeters cubed. Significant figures, let's take a look. 10.25 has 4. That zero's in the middle. Middle zeros are always significant. 2.7 has 2. I always round to the lowest number of significant figures. Remember that 1 doesn't count. So my answer should have 2 significant figures. And the second type of problem that we're going to look at today are, I call them multi-step problems, but how you're going to recognize them is if they have 2 prefixes. So these are just metric conversions, but a little bit different because instead of going from grams to kilograms, where only one of the units has a modifier on it, both units are going to have a modifier on it. So maybe milligrams to centigrams. How do you do that? Well, I try to remember if there's 2 prefixes, a nice little shortcut for that is that I'm going to use 2 parentheses. If you think about those 5 conversion factors that I've asked you to remember, kilo, and then centi, milli, micro, nano, those are the 5 that you need to know. But one thing I haven't asked you is to go in between them. For example, how many millimeters in a centimeter or how many nanometers in a centimeter. Those are all conversion factors that are known quantities, but it's just more information to learn when you could just use those 5 that you already know and still solve these problems. So number 36 says convert 45.20 centimeters to millimeters. So instead of learning how many millimeters are in a centimeter, I think of this as going from centimeters to meters because I know that conversion factor, and then from meters to millimeters. And so think of each one of those arrows as being one conversion, one set of parentheses. So 45.20 centimeters. What conversion factors am I going to use? Well, I'm going to use 100 centimeters equals 1 meter. And 1,000 millimeters equals 1 meter. So the first thing I'm going to do is convert to that base unit. We're always converting to the base unit in the first parenthesis. So 100 centimeters, 1 meter. Now, in the second parenthesis, I'm going to convert from the base unit to the unit that I want to find, right? The question's asking me how many millimeters. So 1 meter, again down bottom, and 1,000 millimeters. So plugging this into my calculator, 45.20 divided by 100 times 1,000. And I get 452.0 millimeters. And it is important that I keep that 0.0. This number has 4 significant figures. That 0 was measured, it's significant, it's at the end, but there's a decimal point in the problem, so that must mean my answer must also have 4 significant figures. When you plug this in your calculator, your calculator most likely will not give you that 0 back, but you need to add it in because at the end of every problem, we always check for units and significant figures. Look at how our units cancel out: a centimeter in the numerator and the denominator, a meter in the numerator and the denominator. The only unit that didn't cancel out is millimeters. If you feel confident, you can pause and do the next 2 on your own or keep going and follow right along. How many milligrams are in 0.0046 kilograms? So 0.0046 kilograms. Remember, the first parenthesis, I'm going to go to the base unit. So I'm going to convert kilograms to grams. And the next parenthesis, I'm going to go from grams to milligrams. I'm going to go to the unit that I want my answer to be in. So what are my conversion factors? Go back, if you haven't memorized them yet, that's fine. Go back and look them up. It's 1,000 grams equals 1 kilogram, and 1,000 milligrams equals 1 gram. So now I'm placing my conversion factors in there so that the units work out. In my calculator, 0.0046 times 1,000 divided by 1 times 1,000 divided by 1, and so I will get 4,600 milligrams. Let's check significant figures here. Beginning zeros are never significant. This number only has 2. My conversion factors with the metric system never count, so my answer should just have 2. I don't have to put a decimal point in the 4,600 because zeros at the end are not significant if there's no decimal point in the problem. My units cancel out, 4,600 milligrams. Next problem. Convert 3.66 times 10 to the positive 3 nanograms to centigrams. So I'm going to take nanograms and convert it to grams. I always go to the base unit in the first parenthesis, and the second unit I go in the second parenthesis. I go from the base unit to the desired unit. What are the conversion factors? 10 to the 9 nanograms equals 1 gram, and 100 centigrams equals 1 gram. 3.66 times 10 to the positive 3 nanograms. So in my first parenthesis, 10 to the 9 nanograms on the bottom and 1 gram on the top. In my second parenthesis, 1 gram on the bottom, 100 centigrams on the top. Now, of course, there is a way to know how many nanograms are in a centigram. A nanogram is smaller than a centigram. A certain number of them will fit into 1 centigram. But that's just another thing for me to memorize. So this is how we can do these problems without that extra memorization. In my calculator, right, this number is in scientific notation. So 3.66 second comma to get the small but uppercase E, 3. And then I can multiply by 1, but we know our calculators don't need us to do that. Divided by 10 caret 9. That number is not in scientific notation. There's no stem to it, so we leave it blank. And then times 100. That's what I'm plugging into my calculator. When I do that, I should get 3.66 times 10 to the negative 4 centigrams. And checking over units and sig figs, this number has 3. My metric conversions don't count for significant figures, so my answer should have 3. Nanogram in the numerator and the denominator cancel. Gram in the numerator and the denominator cancel. So the only unit that I have left is centigrams.